Question number 65. It is from June 2020 mathematical science paper. For P belongs to this real space R, consider the improper integral. This IP is integral 0 to 1 t to the power p sine of t dt. This is the improper integral, and we have to find which of the following statements are true. So we can also write IP as 0 to 1 sine of t by t to the power minus p dt, right? You can simplify it, and we have a result. The thing is that this 0 to 1 sine x by x to the power n dt, so these will converge if n is greater than 1. This is x to the power n. Okay, it will converge for n greater than 1, and it will diverge for n less than equal to 1. So here minus p greater than 1, then IP converges, and minus p greater than less than equal to 1, then IP will diverges. So we can also write it in a this manner. This convergent condition will be when p is less than equal to minus 1 and the divergent condition is p greater than equal to minus 1. Okay, so now check with the options. So for the first option, p is equal to half, right, which is greater than equal to minus 1. So this IP, it will diverge, but it is showing the convergence, so it is a wrong answer. Wrong option. So check with the option 2. Here p is given as minus 3 by 2, which is less than minus 1, so it will converge. So it is also a wrong option. Check with the option 3 and 4. Okay, so first with 3, what is 3 staying? So p equal to 4 by 3. Okay, which is greater than equal to minus 1, so it will diverge. Okay, so there is a typing mistake over here, this in the problem. So here p is given as minus 4 by 3. Okay, so for that we have to find whether it is convergent. So if it is minus 4 by 3, then it is less than minus 1, so it will converge. Okay, so this is true. And similarly for 4, here p is equal to 4 by 3, so there is a interchange of the negative sign, okay, in the option. So it is 4 by 3, which is greater than minus 1, and it will diverge. So it is also a correct option. So kindly check with the options 3 and 4. So it is plus 4 by 3 and it is minus 4 by 3. So in our option, the two this problem, in the two options will be correct, the option 3 and option 4. Suppose the question number 66. Suppose fn is a sequence of real valued functions on the real space R, and suppose it converges to a continuous function f uniformly on each and close bounded subset of R. So we have to find which of the following statements is true. So here it is, you can see that it converges on a continuous function f uniformly on each and close bounded subset of R. So it is converging, converges compactly. Okay, so it is clear that the sequence Fn converges to F, okay, pointwise on the real space. So here you can check with the option 2, which is the correct option. So it's the sequence Fn converges to F pointwise on R, as the function f, the continuous function f, it is converging to the continuous function f on each and close bounded subset of the real space R. Now we have a result. The result states that if x and tau is a compact space, okay, and Fn is mapping on F compactly, then Fn will map to F uniformly also, right? So here R is not compact, so we can eliminate the option 1, right? Let us consider, so let us take that f of nx is summation of j equal to 0 to n to the power x to the power j x to the power j by j factorial, right? And with fx is equal to e to the power x, okay, at every x. Or we can consider that this fx is equal to e to the power x. Okay. Now we know a power series in x converges at every x, then the convergence is uniform on any compact set. For a power series, okay, a power series in x converges at every x, then the convergence is uniform, right, on any compact set. But we know that Fn is a polynomial. This f on n is a polynomial, and also the e to the power x minus of px, it will tend to infinity as x tends to infinity, right? So for any polynomial p, that f and x will not converge. It will not converge uniformly to fx. Okay, so we can eliminate the option 1, and also for, so we can this option 1, it can be eliminated, right? And also for very large values of n, this sufficiently large n, that is our option given, sufficiently large value of n, this function that we have considered, the fx is equal to j equal to 0 to n x to the power j by j factorial, is not bounded for large value of n. So hence option, we can eliminate the option 3 also. So our correct option is only the option 2. So in our case, the correct option will be option. The sequence Fn converges to a point is f pointwise on the real space.